Induced pluripotent stem cells are very important to medicine and regenerative medicine in particular because they circumvent some of the issues related to embryonic stem cell use. Embryonic stem cells are difficult to obtain, and there are ethical questions and issues involved with their use. Induced pluripotent stem cells come about from converting a normal body cell into a pluripotent stem cell using either, in the case of the classic manner, 4 different proteins or transcription factors, or in the case of our new methodology, microRNAs. The ability to do this allows us to be able to make stem cells from any individual person, and then in the future hopefully be able to reconvert them back to usable cells to regenerate tissues and organs in the body. The reason this finding is important is because all the other methodologies have used one or more of these 4 transcription factors. We've now been able to show that you do not need to use these transcription factors. You can actually use a totally different methodology that doesn't involve either transcription factors or translated proteins. And microRNAs also have the ability to be easily transfected into cells. So this opens the way to doing this without the use of viruses, which has been the standard methodology in the past. And one really important finding from our studies is that microRNAs are able to do this in a much more efficient manner. We're able to show that you can use microRNAs, and by doing so, you can do this at 2 orders of magnitude more efficient than with the standard transcription factor cocktail that people have previously used. For example, if you normally take 100,000 human fibroblast cells and using the classic 4 transcription factor cocktail, you generally get a small handful of cells, clones, anywhere from 3 to 4 clones to say a dozen, maybe 20 clones at most. With the microRNA reprogramming process, we get upwards of 10,000 clones with the same number of cells and same starting amount of virus. So you're talking about 10% of the cells actually get converted to pluripotent stem cells using the microRNAs. So we originally discovered this microRNA in our studies looking at early lung progenitor stem cell development. This microRNA came out of a screen as microRNAs that were downstream of a different transcription factor that was involved in very early stages of driving early lung endoderm progenitor proliferation and differentiation. So we looked at this microRNA and found through the literature that it was highly expressed and overrepresented in embryonic stem cells also. So we asked a simple question: could expression of this microRNA, which is highly expressed in embryonic stem cells, could expression of this microRNA in a non-embryonic stem cell convert that non-stem cell to a stem cell? Surprisingly to us, it worked the very first time, and that was a shock to us because it's not that easy to convert non-stem cells into induced pluripotent stem cells. This methodology worked the first time, it's worked pretty much every time we've done it, and it's worked at a very, very high level of efficiency. So what we've been able to do up to this point is to take a person's cells, skin cells or some other normal adult cell, convert them backwards to a pluripotent stem cell. And in the near future, what we're able to hope to do with these cells now is redifferentiate them into heart cells, liver cells, nerve cells, and other useful cells in the body that can be used to replace damaged organs or tissues. So the other authors involved in this study were Fred Danso, who's a postdoctoral fellow in my lab, and John Epstein here at University of Pennsylvania was also involved in the studies.